Well, here we are. We're going to be making some transformations to this original function, y equals f of x, to make it look like this. Once we figure out what the transformations are that take us from this function to this function, we'll apply those transformations to y equals f of x, and hopefully end up with one of those. So to begin with, it appears as if we have a horizontal compression. So let's see if we can measure that horizontal compression. Our original horizontal distance there is 4 in comparison to the new distance of 2. So we're thinking about a horizontal compression. Our scale goes from 4 to 2, which is a factor times 1/2 if we reduce that. So thinking about a horizontal compression, x is transformed into kx, where if k is bigger than 1, we have a horizontal compression. The compression factor in this case, or k in this case, is the reciprocal of 1/2, or 2 over 1, or in this case 2. So x becomes, does it have to do that? X becomes kx, or in this case 2x. If we draw our new function, it will go like this. Every point will be compressed horizontally by a factor of 1/2. So this is the point 2, 0. Being compressed, the x-coordinate will get multiplied by 1/2. The y-coordinate will remain unchanged. It becomes now the point 1, 0 right there. This point here is -2, 0. Compressing the x-coordinate by 1/2, 1/2 times -2 gives us -1, and the y-coordinate remains unchanged. So there's -1, 0. You can see that we now have the same basic shape. Maximum, of course, is unchanged. What we now have to do is we now have to move it to the right. And we take a look at that point there, for example. Clearly, it's gone from there over to there, which is a horizontal translation right 3. Horizontal translation is x to x minus k. K bigger than 0, positive, will move us to the right. And so we want x to become x minus 3, the distance that we move to the right. So we now have our two transformations. Let's see if we move this over 3. We go 1, 2, 3. This point moves over 1, 2, 3. This point moves over 1, 2, 3. We can draw a new graph and see that in fact we've arrived at this transformed graph. So these are our two transformations. Starting off with y equals f of x, we're going to apply the two transformations in order, remembering that first we're going to do the compression and we must do the translation next. So first with the compression, y becomes f of, and we're going to replace our x with kx, or in this case y equals f of 2x. Here's our first transformation. Next transformation is x to x minus 3. So we're going to take y equals f of 2, and I'm going to put some brackets where x belongs. And the reason I'm going to put some brackets there is to ensure that I physically replace x with x minus 3. And this is an important part of the step. There you can see that x has been replaced with x minus 3. It doesn't simply become 2x minus 3. Right? I physically have to replace the x. So now thinking about what our new equation will be, I've got y equals f, and I'm just going to multiply through using the distributive property here, 2x minus 6. That's 2 times 3. So y equals f of 2x minus 6 appears to be D.